Okay, so this is the velocity versus time graph. It's the back side of this sheet that we went over today in class. So we did the displacement versus time graph. So this is sheet number 1. Okay, so it's graph number 1, not the second one, but the first one. So the back side, and I promised that I would do a video of the results, the answers here, so that you could see if you got it before you worked on number 2. So remember, on a velocity versus time graph, the slope is the acceleration, and to get the velocity, you just read it off the side. So the first question asks, what was the object's maximum velocity? Well, we're going to read the velocity off the side. So the maximum velocity is going to be the highest point and the lowest point, because remember, the negatives just mean the direction. So this object ends up going fastest 30 meters per second west down here and east up here. So it has two maxima velocities simply because the east and west are the same. So you would write 30 meters per second east and 30 meters per second west. If west was actually negative 35, then you would only write one of them, because 35 meters per second west would be bigger than 30 meters per second east. What was the object's velocity at 5 seconds? So remember, on a velocity versus time graph, you just have to read it off the graph. So go to 5 seconds, go down, hit the graph line, and then go across. And when you do that, that's 10, so this is 15. It looks like it's about 17.5 meters per second, and it's asking for velocity, so you need a direction, and it's on the lower part of the graph. It's a negative, so it means west. What was the acceleration? Number 3, what was the acceleration at 5 seconds? So at 5 seconds, to find the acceleration, you need to find the slope. So this goes back to in class today when I was saying you don't have to pick the point that they give you. You just can pick any 2 points on the line. So pick the endpoints, because I estimated that to be 17.5, but we don't really know that it is. But we know this point is 3.5 seconds and negative 30 meters per second. And we know this point up here is 7 seconds and 0 meters per second. And so we're going to find the slope. So I'll do it right here. The slope, which will be the A, is the change in y. So 0 meters per second minus a minus 30 over the change in x. And so since I started with the 0, I have to start with the 7 seconds minus 3.5 seconds. On the top, that's positive 30. On the bottom, positive 3.5. And so when you do 30 divided by 3.5, you get 8.57 meters per second squared. Works out to be positive. That means it's east. Now, you might think that's weird that it's east, but look at what it's doing. It's slowing down from negative 30 meters per second to 0, so it's slowing down, but it's going west. So the slowing down going west, slowing down would be a negative, going west would be a negative, and so the acceleration is positive. If it's slowing down going west, the acceleration must be acting in the opposite direction, which would be east. Number 4, when did it have constant velocity? It has constant velocity whenever the slope of the line is 0. So it's in several spots. It's at 2 to 3.5 seconds. So 2 to 3.5 seconds. It's from 7 to 8.5 seconds, and that's 0, but it's still constant, 8.5 seconds. It's from 11 to 11.5 seconds. And really, it's out here. It looks like this is still constant velocity. It's still continuing. So 13 seconds to 14 seconds. Those are all the spots with constant velocity. When did it have negative acceleration? When was the slope of the line negative? It would be from 0 seconds to 2.5. Here it's speeding up, so you might think, wait, that's positive acceleration, but it's speeding up going west. And so the acceleration itself would be negative. 0 to 2 seconds. And the other spot is over here where it's slowing down going east from 11.5 to 13 seconds. So 11.5 to 13 seconds. And this part goes with that one. When did it have negative velocity? That part should be easy on a velocity versus time graph. It has a negative velocity whenever it's below the x-axis. This dude is going west from 0 to 7 seconds. It's speeding up going west, constant velocity going west, slowing down but still going west. So when did it have negative velocity? From 0 to 7 seconds. What was its displacement at the 3.5 second mark? Now, we didn't have a lot of time to talk about this in class today, like none. But for a velocity versus time graph, and you'll see it in your notes, to find the displacement, you find the area under the curve. Okay, so if we want the area, we want the displacement at the 3.5 second, we need to find the area of this triangle, the area of this rectangle, and add them together. Area of a triangle is 1/2 the base times the height. The base is 2 seconds. The height is minus 30 meters, so that's negative 60. Half of that is 30. Really, it's negative 30, but the negative just means west. In the rectangle, it's 2 to 1.5 seconds times 30 meters per second. So that's 45 meters. It's still negative, so 45 meters west. So what's the total displacement? 75 meters. And it's displacement, so we need our direction, so west. 75 meters west. Okay? What is the distance that it moves in the first 7 seconds? So now, distance is also area underneath. The difference between distance and displacement is if you're adding these two, if you're using the whole section, this one would be positive, this one would be negative, and for displacement you'd subtract them, distance you would add them. So we need this triangle right here to complete our 7 second. Its base is 3.5, its height is still negative 30. And so you get 105 and take half of that. I think it's 52.5 meters. And the negative still means west. So what was the distance? Add them all up. So add 75 to that 52.5. And get 127.5, I believe. And this time it's distance, so you do not need a direction. When did the object first start to travel east? Well, I said a few minutes ago, it's speeding up going west, constant speed going west, slowing down going west, stopped. Now it starts to speed up going east, constant speed east, slowing down going east, and stopped again. So when did it first start to travel east? At 8.5 seconds. What was the total displacement? So again, area underneath. We already found the area under the first one. We now need to find the area under this second set. So 2 triangles and a rectangle again. The base of this triangle is 2.5. The height is 30. So that's 60, 75. Take half of it. So 37.5 meters. It's positive this time. So it's east. This little strip is 1/2 times 30, so it would be 15, because it's just base times height. And this is back to a triangle whose base is 1.5 times 30, so 45. Take half, 22.5 meters, and again positive. So all of these are east. So a few minutes ago we had added this one up, and we had